All right, it's a little bit after 8. Welcome to our night review. Good evening, everyone. I'm Mr. Huber. Thought this would be kind of a fun way to help review for your upcoming Algebra 2 Unit 2 test. All right, so I figured we might as well kind of look at our review for that test, make sure that you guys got all the right answers for those. And hopefully that will kind of give us a nice little overview of what our test will look like. I'm pretty sure our live chat is working. I'm not exactly sure. This is my first time using YouTube Live, and I linked it to my Zoom account. So we'll see if this kind of works and we can make adjustments as we go. I posted a couple things in our live chat. So if you're able to respond or you have specific questions, why don't you try those out? Otherwise, I'll also post a Zoom meeting link at the end where you can jump in and ask me any questions that you might have at the end of our review as well. All right, so I'm going to go ahead and share my screen. And this might not be the exact review that your teacher gave you because we have quite a few Algebra 2 teachers. It might look a little different. However, it is the same type of problems. And this one specifically follows kind of the format of your test. So I chose to look at this review today. All right. And it starts a little out of order. But this first target is I can solve absolute value equations and inequalities. All right. So when we're looking at absolute values, okay, if we have something like the absolute value of 4, well, that's going to be equal to 4. But so is the absolute value of -4. So for that reason, all of these have a positive and a negative solution. All right. So when I'm looking at these, okay, first let's look at the positive solution. So that would be x minus 8 is equal to positive 2. But then we also have the negative solution where x minus 8 is equal to -2. Now, all we would have to do is solve these two equations to give us our two solutions that would be our x values. All right, so I'll start with my green one over here, my positive one. I'm going to go ahead and do the opposite operation of subtraction. I'm going to add a positive 8 to both sides so that these cancel and I get x by itself, which x would be equal to 8 plus 2, which is 10. I can do the same thing in this equation over here. However, now with that -2, x is going to equal to 8 plus a -2 is going to give you 6. So these would be my two solutions for x that I could plug in to this absolute value, and both of those would give me a solution of 2. All right, moving quickly on to number 2. Same idea here. I have 3x minus 2 is equal to a positive 4. And we also have a 3x minus 2 is equal to a -4. We're going to go ahead and solve these two equations. Now we have a two-step equation. All right, so we're going to add 2 to both sides. I get 3x is equal to 6. Divide each side by 3 so that we get x is equal to 6 divided by 3 should give you 2. And now let's do the same thing with our -4 solution. I'm going to add 2 to both sides again. I get 3x is equal to -4 plus 2 should give you a -2. Divide each side by 3. X should be equal to -2/3. So these would be our two solutions for number 2. All right, number 3, we get a little bit trickier. Same idea though. All right, again, we have 2, the absolute value of x plus 4 minus 2 is equal to 16, and 2 times the absolute value of x plus 4 minus 2 is equal to a negative 16. All right. Again, I'm going to go ahead and get rid of that subtraction. So I'm going to add 2 to both sides. So I have 2 times the absolute value of x plus 4 is equal to 18. All right, here's where it's a little bit different. This 2 is multiplied by that x plus 4 in that absolute value. Before, when it was in parentheses, we were normally using that distributive property. Now, because it's an absolute value, we really just want to get rid of that 2 right away. So let's go ahead and divide each side by 2 so that I'm left with my absolute value of x plus 4 is equal to 9. All right, and then we can subtract 4 on each side so that I get my solution. X is equal to 5. All right, and we can do the exact same thing for this one here. Add 2 to both sides. I get 2x plus 4 is equal to negative 14. Divide each side by 2. X plus 4 is equal to negative 7. Subtract 4 on both sides. X is equal to a negative 11. All right, so these would be how we would solve equations that have absolute values. All right, so I guess we can kind of test out our live chat, see if anybody's able to post in there. Maybe I'll try to say something. If not, we'll kind of just keep working through our review. All right, then we'll just keep going. Let's look at our next one. Our next target is that we can graph some lines written in 3 different forms. All right, now let's review those forms quickly. Your first form is number 4. That's going to be what we call slope intercept form. All right, that is y is equal to mx plus b, where this m is your, well, let's not do it in yellow, is your slope, and this b is going to be your y intercept. Okay, so if we look at this example, negative 2/3 would be my slope, and positive 6 would be my y-intercept. So now we just have to graph this. So we need a point to start at, and that's going to be that y-intercept. Your y-intercept is where that point crosses your y-axis, or where that line crosses your y-axis. So we're going to go to positive 6. So we'll count up 6. 1, 2, 3, 4, 5, 6. That's our y-intercept. And now we'll take a look at our slope. A negative slope is always going to go up and to the left. So your line will look something like this. So in this case, slope is always rise over run. So we want to go up 2 and then left 3. All right. Up 2, left 3. So I'll zoom in, up 1, 2, left 1, 2, 3. Okay, or you could go down and to the right. So I'm going to go down 1, 2, right 1, 2, 3. All right, now if we connect these points, that will be a graph of our line. Cool little trick. If you have a wiggly line, just hold it down at the end, and on Notability, it will make it straight for you. Makes your life a lot easier, and it makes a nice line when you're done. All right, so that is slope-intercept form. Slope-intercept form, I think, is probably one of the easiest ones to graph. That's kind of my favorite. This one, again, is in slope-intercept form. So it's nice and easy because it's mx plus b. M is slope. I don't know why they use m to abbreviate slope, but this would be my slope, which some people are like, well, it's rise over run. Well, 4 is really 4 over 1. So if you ever have a constant, that whole number like that, it's really over 1. All right, and then don't forget this negative on our y-intercept. All right, so we want negative 10 as our y-intercept. So that's going to be all the way down here. All right, and we want a positive slope this time. So positive slopes go up and to the right. So our graph should look something like this. All right, so we want to go up 4 and then right 1. So up 1, 2, 3, 4, right 1, up 1, 2, 3, 4, right 1. Let's go ahead and draw my line, hold it down to get it to be straight. And there we go. Slope intercept, check. All right, the next form we're going to look at is point slope form. So slope intercept gave us the slope and the y-intercept. Point slope form gives you the slope and a point. All right, clever name, right? So a general formula for point slope form is y minus y1 is equal to m x minus x1. All right. This m, again, is our slope. All right, but then we're also given a point. So we have the point x1, y1. Now, what you have to watch out for, all right, is these minus signs here. That means the opposite. All right, so we'll look at an example and it will make some more sense. All right, so if I look at this one right here, I can see my slope is this -2. All right, and then my point, well, here's your x value, and see how it's a +2? So we have to do the opposite, which would be a -2. And our y value is a positive 1, so we have to do the opposite, which would make it a negative 1. So now we'll plot our point -2, -1. -2, -1 should be right about here. Okay, always look to see if your slope is positive or negative. It's negative, so it goes up and to the left. All right, and it's -2/1. So we want to go up 2, left 1, up 2, left 1. So let's go ahead and do that now. Up 2, left 1, up 2, left 1, up 2, left 1. And now we just connect our points. All right, so that is a quick review of 2 of our types of graphs for lines. All right, the third way you'll see, and I don't really like this way, is called the standard form. So the standard form of a line is ax plus by is equal to c. All right, so it might look something like maybe 3x plus 2y is equal to 12. All right, and the reason I don't like standard form is because right now, this doesn't tell me anything. It doesn't tell me the slope. It doesn't tell me a point. It doesn't tell me the y-intercept. So we would have to change this equation a little bit to make it look like slope-intercept form in order to then graph it. All right. So standard form is probably our least favorite. All right, on to target number 8. I can graph transformations based upon the parent graph: linear, absolute value, cubed root, and quadratic. All right, here we go. So if you ever get confused, I would make a little t-chart. Okay, so this one right here, I see we have an absolute value. So that means my parent function is just going to be the absolute value of x. So in my t-chart, I can plug in some values for x, and I usually use the values -2, -1, 0, 1, and 2, because that gives me a pretty good picture of the graph. All right, if I took the absolute value of -2, that would give me a +2. If I took the absolute value of -1, that would give me y value of 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So now I can plot these points. So I'm going to start at 0, 0. We have 1, 1. We have 2, 2. We have -1, 1. We have -2, 2. So I start to get an idea of what the absolute value of x graph looks like. Looks like a giant V. But now we're going to talk about some transformations. Okay, so this looks a little different. It's got a couple elements added to it. The first is this -2, and the second is this +1. All right, so if we ever have something within the absolute value, like that -2, that's going to tell me if the graph shifts left or right. And then outside of your absolute value is going to tell you if that graph shifts up or down. Okay, now up and down is easy. It's exactly what you would think. Positive shifts your graph up toward all these positive numbers, and negative shifts your graph down toward all the other negative numbers. But in here, it's backwards. All right, so see how this is a negative? Well, negative actually shifts your graph to the right, and a positive shifts your graph to the left. Okay, so we just need to know that that one's kind of backwards. It's almost the opposite of what we would have thought. So I'll write that in there. All right, so now what I can do is I can use my parent function and I can go and I'm going to shift this graph right to, we'll write this down here, right to, because it is a negative, and then I'm going to shift it up 1 because it's a positive 1. So I'll write that down here at the bottom. Up 1. So now I'll just go to each of these points. I'll shift it right 2, up 1, 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 right 2, up 1. And you can see our new transformation. So the black graph would be our parent function. So that was this y is equal to the square root of x. And then our blue graph is this transformation with that absolute value of x minus 2 plus 1. But now let's look at another example where we're looking at a square root. All right, so I'm going to get an idea of what the parent function looks like. Remember, square roots, you can't do square root of a negative number. So that pretty much cancels out this whole half of the graph. So I'm going to say, okay, y is equal to the square root of x. And we'll do maybe the square root of 1, 2, 3, 4. Square root of 1 is just, well, we'll do 0 too. Add a 0 in there. Square root of 0 is 0. Square root of 1 is 1. Square root of 2, that's not a nice number. I think you'll get something like 1.3 or 1.4. Okay, so that doesn't help us out too much. Square root of 3, I think you'll get something like 1.7. Square root of 4, that's a nice one, 2. And then we could kind of cheat a little bit. We know what the square root of 9 is. Square root of 9 is just 3. So I got a couple of points that I don't really want to graph. All right, but these 4 points I can graph. So I'll graph 0, 0, 1, 1, 4, 2, and then 9, 3. So I kind of see it's going to look something like this. That would be our parent function. Now, just like our last example, if it's under the square root, kind of like if it was in the absolute value, this is going to tell me left or right. And then this one at the end is going to tell me up or down. Okay, remember, left and right is backwards. So right is negative, left is positive, up and down is what you would think. All right, so since it's negative, we're gonna go to the right one. So I'm gonna write that on there. Right one. And then we are going to go, ooh, this is now a negative 5. So we're gonna go down 5. So let's go to each of my points, go right 1, down 5. Right 1, down 1, 2, 3, 4, 5. Right 1, right 1. Then there is my transformation. Okay, so I think those were our only target 8 questions. right? And I wish I could see if we had any questions. I'll figure out that live chat. All right, moving right along. Target 1. I can evaluate and identify functions with function notation. All right. So a function, okay, you are going to have one input gives you an output, right? You can only use an input once, all right? So we can't repeat X values, but we can repeat Y values. All right, so if I look here, I see 2, 3, 5, 3. Uh-oh. We repeated an X value. Okay, that means we have two inputs that are giving me different outputs. All right, so if you kind of think about this on a graph, well, the point 3, 2, 3, 2 would be here, and the point 3, negative 1 would be here. Okay, we can do what's called the vertical line test. So I draw a vertical line, and all of your vertical lines can only hit 1 point. This one hits 2 points, which means that it is not a function. So I'd say, no, not a function. All right, our domain, I'm always looking at X values. All right, so I would just say, and I'm gonna write it in set notation. That's what those little squigglies are. They're a little hard to draw. I'm gonna try to do it in order from least to greatest for my X values. So I have 2, 3, 3. 2, 3, 3, 5, 6. So those are all of my X values. Now my range is all my Y values. All right, so that would be 1, negative 1, negative 1, 1, 2, 4, 5. Okay, but we can also find domain and range from a table. So let's go ahead and look to see if any of our X values are repeated. I see 0, 1, negative 4, 3, negative 5. So we have nothing repeated in our X's. Let's see if we have anything repeated in our Y's. Nothing repeated in our Y's. But if you do repeat in your Y values, that's okay. Because that would be like saying you have 1, 3, and negative 1, 3. So vertical line, they both only hit 1 point. So that's all right. So we can repeat Y's, but not X's. Is this a function? Yes. Domain, let's list my X values from least to greatest. So I'm going to say negative 5, negative 4, 0, 1, 3. In my range, I'm going to say negative 5, negative 1, 0, 1, 3. All right, and this one is kind of a web. If you wanted to, you could write all of these out and you could say, okay, well, this is negative 8, 7, negative 1, 9. And you could keep going with all of those. But look, you're going to have 15, 7, and you're also going to have 15, 9. We can't have that. That is two inputs with a different output. So that would make this not a function. All right, and because of, let's do it in red. So why is this not a function? because of that 15. It has two different outputs. All right, so my domain, let's go ahead and say my domain would be -8, -1, 0, 15. Your range would be 7 and 9. Okay, so that's how we can tell some functions. So I like to sometimes play a quick little game. Is it a function or not? So let's play that really quick. Function or not? Okay, well, remember that vertical line test. Draw a whole bunch of vertical lines and see how all of them are only hitting one point on my graph. That would mean that this is a function. What about this one? Well, if I drew a vertical line, see how it goes through 2 points on your function? That means that this one's not a function. Nope, this one would not be a function. What about this one? Is this graph a function? Again, we draw a vertical line. Hits 2 points, so no, not a function. All right, time to get a little bit trickier. What about this one? It's pretty close, but it is a function. All of those only hit 1 point on your graph. Last one. Let's do, what about this one? A lot of people are saying, I think it is a function because I can draw vertical lines. But what about this vertical line? This hits a whole bunch of points. So this one would also not be a function. All right, good quick review of function or not. But now what happens when we evaluate? Now you gotta be careful what you're looking for in these. This is always f of x. So in this case, notice how your -3 is your x value, which means I'm going to take -3 and plug it in for x. All right, so I have f of -3 is equal to -2 times -3 minus 5. So f of -3 is equal to -2 times -3 is going to give you a positive 6 minus 5. F of -3 is equal to 6 minus 5, which is just 1. So our answer here would be f of -3 is equal to 1. Or when x is equal to -3, okay, your answer would be, or your output would be 1. All right, on to target number 2. We're gonna look at domain and range. So domain, we're always looking left and right, and range, we're always looking up and down. Okay, so domain left and right. So I kind of draw this graph and I know that this keeps going in this direction. See how it's still going to left, still going to left? Well, it's actually going to go to the left forever. So we have to count, well, this would be -10, -11, -12, and so on. So it's going to go to all of those negative numbers all the way to negative infinity because it's just going to keep going on forever. All right. But it also keeps going to the right forever and ever and ever. And these are now positive numbers. Okay. So it also goes to the right to positive infinity. Okay, so that was our left and right of the graph. Now we look up and down. So now we're going to look at range. Notice that it only goes down to that point right here at y is equal to 2. So I'm going to say, well, the bottom is 2. Well, could it be on 2? Yeah, it is on 2. It's filled in on 2. That's what this bracket means. So this bracket means included. Okay, so that's why I put a bracket on that too. And then we say, well, how high up does it go? Well, if you extend our line, see how it's going up, 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 up. And it also goes in this direction and just keeps going up forever too. So this one is going to go up to positive infinity. It's just going to keep going up forever. Make sure that that one is a parenthesis because you can't actually have a point on infinity, right? It just keeps going on forever. On to number 14. So we start left and right. So I start on the left side. Notice that this is continuing to the left forever toward all those negative numbers. So it's going to go to negative infinity. However, it only goes as far right as this point right here at x is equal to -2. So I'd say -2. And notice that it's a filled in circle on -2. So we have to include that by putting that bracket. Range, again, is up and down. So its lowest point, it's not going to go below this x-axis where your y value is 0. But it could be on that y value is 0. And now we say, okay, well, how high up does it go? Well, it might be gradual, but this keeps going up and up and up forever. So we'd say positive infinity for that range. All right, this is where we get a little tricky. So again, let's look left and right first. So I see left, we go up to this point here and it's filled in. So that means it's included. So I'm going to put a bracket right away. This I'm going to count -1, -2, -3, -4, -5, -6, -7 over to the left. But now how far to the right? Well, it goes right here, but notice this one is an open circle. That means it can't be on that point. So when it's open, I just leave it a parenthesis. It's not included. But that would point, that open circle would be at 1, 2, 3, 4, 5. X is equal to 5. So that covers left and right. It means that your graph is all in between these points here. Now let's talk about, now let's talk about up and down. So our lowest point is right here. And that would be at -1, 2, 3. And it's filled in, so it's included. So I'd say -3. And then it goes up to this point here, which is open, so it's not included. So again, I'm going to use that parenthesis then. And that would be at y is equal to 1. So I'm just going to put 1. So they're all between -3 and 1, which makes sense because -3 and 1 gives you 1, 2, 3, 4. units. So they're all right in here. Cruising right along on this review. All right, target 5. I can write linear equations in slope intercept and point slope form. Whew, here we go. It says find the slope. Well, in slope intercept form, that is very easy. Our slope is right here for us. So I would just say slope is equal to negative 2/3. Or it doesn't matter if you put that negative with that 2 or if you write it out front like this. Either way. Number 17. Remember, slope we can also say is rise over run. So our rise is 1, 2, 3, 4 over our run. Well, let's put 4 over our run, which is 1, 2. Now, very, very important. Notice this is up and to the left, which makes this negative. So I'm going to say negative 4 over 2. Or if we simplify negative 4 over 2, well, negative 4 divided by 2 is going to give me negative 2. So in this one, our slope should have been negative 2. Or negative 2 over 1, that's fine too. Uh-oh, here we get a little bit trickier. All right, so just like this one, we could use a graph. So we could graph these 2 points. We could say, okay, 5, 3 would be right about here. All right, and negative 4, 6. That would be right about here. All right, and then we can say rise over run, right? Or a little bit quicker way of doing this is with this formula. M is equal to the change in y, or y2 minus y1, over x2 minus x1. So where does this equation come from? Well, it's calling this first point x1, y1. Oops. And that's calling this second point x2, y2. All right, so this is point 1 and this is point 2. All right, so first we need the change in y. So y is kind of like that range, okay? So we can see, okay, well, our change in y is 1, 2, 3 down, right? Or if we were plugging it into this equation to find that change of y, we take y2, 3, minus y1, 6, and 3 minus 6, well, we could also change that to addition of a negative. All right, so that would give me negative 3. And then you're like, oh, well, that makes sense because it's down 3, right? So you could say negative 3 there. And then it's change in x. So that was our rise. Now we want our run, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Did I count that right? I might have missed one in there. Because it should be 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Or we could say x2, 5, minus x1, which is a negative 4. And this is kind of like a double negative. So it's almost like I said, I'm not going to do my homework. Well, wait a second, then you are going to do your homework. So we can change this double negative to be addition of the opposite. So then it's 5 plus 4, which is 9. So that is how we can find our slope of negative 3 over 9. Okay, and it just makes our life a little bit easier using this formula here, because then we don't have to graph it, because graphs take time. And I don't know about you guys, but I've heard of a lot of people that were like, man, I've just been running out of time on the tests. All right, so we want to try to save as much time as we can. So that's why I like that formula. All right, number 19, write an equation in slope-intercept form for the line that has a slope of -3 and a y-intercept of 4. Oh my goodness. On your test, you should skip right to this one because this one's nice and easy. We're writing it in slope-intercept form, so remember that's y is equal to mx plus b, where m is your slope, so our slope is -3, so y is equal to -3x. And then b is your y-intercept, which it told us is 4. That's all there was to this one. Y is equal to -3x plus 4. Done. This one says, write the equation of the graph below in slope-intercept form. All right. So we know y is equal to mx plus b. So let's try to find that slope first. So remember, I want rise over run. So rise is 2. Run is going to the left, so it's going to be negative. So I'd have 1, 2, 3. So then my equation with my slope would be y is equal to rise 2 over -3, or we could move that negative out to the front, maybe. X plus b, b you remember is your y-intercept, or where it crosses that y-axis. So here, that would be at -1. So I just say, you could say plus -1, or I usually like to write it as -1. And that would be all that there is to number 20. Number 21, now we're going to start looking at point slope form. Okay, remember point slope form is that y minus y1 is equal to mx minus x1. All right, and we're given 2 points. Uh-oh. We don't know what our slope is. So what I'm going to do when I'm given 2 points is I'm going to use this formula up here. Okay, so I always start by labeling those points. So I'm going to say, okay, x1, y1, x2, y2. And that formula again is m is equal to change in y over change in x, or 8 y2 minus y1 minus 3 over x2 minus x1, -2. So now, I don't know about you guys, but I'm not a huge subtraction fan. So I like to change subtraction to addition of the opposite. So I say addition of the opposite, addition of the opposite. So now I have 8 plus -3, which should give me 5. And I have 4 plus 2, which gives me 6. So I got my slope is now 5, 6. However, you are not done yet. Okay, so we'll plug that in. So now I have y minus y1 is equal to our slope, which we said is 5, 6. X minus x1. So now we need that point. And notice we actually have 2 points. So it's up to you which one of those you want to pick. So there's 2 different answers you could have for this one. All right. I don't know. Doesn't matter. I'm going to pick this first one. I don't know why. But remember, we have to use the opposite, okay? The opposite of those points. So I start with y. See how y is a +3? So when I write it over here, I'm going to make it a -3. And see how x is a -2? So when I write it over here, I'm actually going to make it +2. 2. All right. So remember, these minus signs mean the opposite of whatever x1, y1 is. All right. If you wanted to use the other point, we would just say that this would be y minus 8 is equal to 5/6 x minus 4. Notice I did the opposite of a positive 8 and a positive 4. Holy cow, we're on the last one of this review already, and we did it in under an hour. All right, this one says, what is the slope of a line perpendicular to y is equal to negative 2/3 x plus 7? All right. So perpendicular lines are going to form a 90-degree angle or a right angle. So they're almost going to be opposite each other on their slopes. However, there's one additional piece of information. Not only are they opposites, but they're also reciprocals. So we need the opposite reciprocal. All right, so what that means, our slope here is this negative 2/3. So I'd say negative 2/3. Our perpendicular slope does the opposite. So instead of negative, it becomes positive. Whoops. All right, but then what the reciprocal means is we have to flip-flop the numerator and the denominator. So my 3 is now my numerator, and my 2 is now my denominator. So this would be my perpendicular slope. Okay, what is the slope of a line perpendicular to this line here? Well, it would be 3/2. That would be your answer. So if I gave you another one, maybe I said, hey, your slope is 1/2. What is the perpendicular slope? This is just kind of an abbreviation for perpendicular too. All right, so again, I have 1/2. I have to do the reciprocal, so flip-flop the numerator and denominator, and then do the opposite. So it was positive, so now it's negative. Or I could simplify this to be a negative 2. That would be my perpendicular slope. All right, and that is it for our Unit 2 test review. All right, we went through all of the problems on there. So hopefully you get a chance to look at those before your test. And in the future, if we try to do one of these again, hopefully we're able to add an element where you guys are able to do the chat. You can ask different questions or ask if you're confused. But for some reason tonight, I couldn't figure that out. I'll look into that for next time. All right. So if you do have any questions, I do want to give you a chance to ask those before you take your test tomorrow. So I'll go ahead and stick around on Zoom. If you want to either send me an email or maybe you guys can see my chats. I'm not quite sure on that. I'll go ahead and post my Zoom link. Or if you send me an email, I will then respond my Zoom link. All right. But I think that's about it for tonight. I hope that you all do awesome on your test. And if you don't, for some reason, maybe you didn't get around to studying this time, I'm available to help with test corrections and retakes too. All right. So come see me for some math help. Have a good one, guys.